Hey friends, welcome back to the channel. Today we're going to talk about balancing redox reactions in both acidic and basic conditions. So we're going to do some problems today, so let's just dive right in. So let's start with our first example here. We have this equation, and the prompt is telling us to do it in acidic conditions. So anytime you see acidic conditions in your question, that tells us that we're going to be dealing with hydrogen plus ions and water addition. So you'll see what that means. I just want you to create this association with acidic, H plus and H2O. So the first step here is to split this into two sort of half reactions. So we're going to take the chlorate ion and the chloride ion and make it into one, and we're going to take the iodine or iodide ion with the solid iodine and make that into a second half reaction over here, which I'm not going to show because I want us to first focus on this one. So let's first focus on balancing this half reaction. So the first question you want to ask yourself is always, do I have any atoms here that need to be balanced other than oxygen? In this case, it's just the chlorine. So does the chlorine need to be balanced on either side? The answer is no, because we have one, an imaginary one over here and an imaginary one over here. So they are balanced. So that only leaves us with the oxygen. Now we have 3 oxygens on this side and no oxygens on this side. But what did I tell you? I told you if we're in acidic conditions, we're going to be adding H plus ions and waters. So this is where the water is going to come into play here. So we're going to add waters which have oxygen. So this water is going to give us the oxygen that we need on this half reaction, on the right side of this half reaction. So how many waters are we going to add? We're going to add 3 waters because we have 3 oxygens on this side. So we need to have 3 oxygens on this side as well, which is why we add 3 waters. Now notice that because we added 3 waters, we have also added hydrogens. We actually added 6 hydrogens. So now we need to balance the hydrogens that are on this side with adding hydrogens that don't originally exist on this side, right? Because we want to make sure we have all the same amount of atoms, and then we worry about charges after. So we need 6 hydrogens. We're going to add H pluses, like I said. We're going to add 6 H pluses. Okay, perfect. Everything is balanced so far, except for charges, which is important here. So let's count our charges. So here we have +6, here we have -1, and here we have -1 as well. Here is 0 because this is neutral. So this overall charge is -1, and on this side, the overall charge is +5. So how do we get from +5 to -1 to make them equal? Well, we're going to add electrons. I'm hoping you're saying it as I go through this example. So we're going to add electrons. How many electrons do we need to add to this side to get it to -1 so that we match this side? So I'm hoping you're saying the answer. The answer is 6 electrons. 6 E minuses is how I write it, electrons. So now our overall charge is -1 on this side because 5 minus 6 is -1. And we have -1 on this side. So we're good to go. Let's take the next half reaction here. So once again, the first question, what needs to be balanced other than oxygen? Here we have an iodide ion, 1 with like a metaphorical or invisible 1, I should say. Here we have I2. So we have 2 iodine ions here and we have 1 here. So that means we need to add a 2 coefficient in front so that they both have 2. Do we have any oxygens here? The answer is no. So we're not going to have to worry about adding waters and by extension H plus ions because there's no oxygen to balance on this half reaction. So all we're dealing with is the iodine. So let's look at the charges now. Here we are at a charge of -2 because we have 2 iodide ions. Here we're at a charge of 0 because it is neutral. So we're going to add 2 electrons on this side so that we can match the electrons or the charge on this side. So now we're at -2 on both sides, as you can see. So we're good to go. So let's just bring these two, completed half reactions now side by side as we have here. And the idea here is to cross out our electrons. We should be able to sort of eliminate or cross out or cancel out the electrons from both half reactions. Now, one thing to notice is at this stage, if you have electrons on opposite sides of the half reactions, you are going in the right direction. If you have, let's say, this 6 electron on this side and this 2 electron stays on this side, both electrons are on the same side, that means you did something wrong, you made a mistake, you might have overlooked something, and you need to reevaluate your half reactions. So here we have them on opposite sides, so we're good to go. Now, before we can actually cross them out, they're not the same number to be canceled out, as you can notice. This is 2, this is 6. So we need to now multiply our half reactions so that we can create the same amount of electrons on both half reactions. So this is 6 and this is 2. Notice that you can multiply this half reaction by 3 so that we can get 6 electrons to match this half reaction that has 6 electrons. So that's what we're going to do here. Let's multiply by 3. So everything is going to get multiplied. So 2 times 3 is becoming 6. 1, an invisible 1 here, times 3 is 3, and 2 times 3 is 6. So now we have equal electrons on both half reactions. This is our new half reaction that we're dealing with. So we're going to cross those out, and we're going to combine the half reactions together. So this is gone, this is gone. So now all we're left is the 6H plus with the chlorate with the 6 iodide ions. Here we have the chloride ion plus 3 waters plus 3 I2. So that is our combined or final equation. So let's move on to this question. So MnO4 minus SO3 2 minus makes MnO2 SO4 2 minus in basic conditions. Okay, so basic is going to be a little bit different, but I want us to associate it like this. Essentially, when you see a basic condition, you want to first balance it as an acidic condition, and then we're going to make some small changes at the end to turn it into a basic balanced redox reaction. So I'll explain that once we get later into the problem solving, but we're going to go and start with balancing this as if it was acidic, and then I'll tell you when we make the switch. Okay, so first of all, once again, we separate into 2 half reactions. So I want you to do that, pause the video and try to separate this out. I'm sure you can identify which molecules go with which ones. So let's create this first half reaction here. So let's think about our atoms here. Do we have any atoms other than oxygen that need to be balanced? And the answer is no. We have an invisible 1 in front of this, and we have an invisible 1 in front of this. So we have 1 and 1, they're equal, we do not need to worry about it. Do we have to worry about our oxygens here? The answer is yes. We have 4 oxygens, 2 oxygens. So we need to get them to, be equal. So how do we do that normally in acidic conditions again? We add water. So that's what we're going to do. We're going to add 2 waters so that we have 2 oxygens that we're adding here. So we have 2 oxygens here plus the 2 here gives us 4 oxygens on this side, which is what we have on this side. But we've added 4 hydrogens on this side. We don't have any hydrogens on this side, so we need to add some in now. So we're going to add the H pluses, the 4 H pluses. So now we have 4 on this side, 4 on this side. Now we're balanced in terms of the atoms. So let's balance the charges. So we're at +4, -1. This is neutral, and this is also neutral. So this is overall 0, and this is, oopsies, we're going to ignore that half reaction for a second. This is +3. So we're going to add 3 electrons on this side so that we can get this side to be neutral, just like this side. So once we add those electrons there, now we're, good to go, and we can move on to our second half reaction over here. So SO3, 2 minus, SO4, 2 minus. Do our sulfur atoms need to be balanced? No. We have 1 sulfur, 1 sulfur. We're good. Do our oxygens need to be balanced? Yes, we have 3 over here and 4 over here. So let's do that. We add 1 water, which gives us 1 extra oxygen. So now we have 4 oxygens on this side, but we've added 2 hydrogens, and we do not have hydrogens over here. So let's add hydrogen on this side, H plus ions, to balance it out. So we're going to add 2 H plus ions because we have 2 over here. Now let's think about our charges. So we have a -2 charge overall on this side. The water's neutral. We have our -2 there. We also have 0 on this side because we have a -2 or 2 minus and 2 H pluses, which is a +2. So they cancel out to make 0. So we need to add electrons to this side so that we can have, a -2 overall charge over here to match this side. So we're adding 2 electrons. So now our overall charge here is going to be -2. Here is -2, so they match. Okay, so I'm just going to bring down the equations down here. So here is the first half reaction that we modified. Here is our second half reaction that we modified. Once again, are our electrons on opposite sides? The answer is yes. So we're going to cross them out. But are they at the right... do they have the right, are they at the lowest common denominator that matches so that they can be crossed out? No, they're not the same number. This is 2, this is 3. So we're going to have to make some modifications and multiply our half reactions so that they become the same. So what's the lowest number that we can multiply this reaction and this reaction so that they match? So the answer is we'll multiply this by 2 to get it to 6. We'll multiply this by 3 to get it to 6. So that's what we're going to do here. Multiply by 2. Everything gets multiplied by 2, as you can see. And this equation here, everything gets multiplied by 3. And so now we have 6 electrons. 6 electrons, they can get crossed out. They will cancel out with each other. Great. We can combine both equations after we've canceled out the electrons. Combine both equations, and we get this really long full reaction. And so as you can see, they have, they're properly multiplied, and we got rid of the electrons here. So what we notice, I'm going a little bit faster, but before we start looking at this full reaction here, I want us to pay attention to the hydrogens, the H plus ions and H plus ions over here. So we have 6 here and 8 here. And actually we can cancel those out as well. So we can cancel the 8 with the 6. 8 minus 6 is going to give us 2. So that's why we have 2 H plus ions on this side, because 8 getting rid of 6 is going to leave us with 2 on this side. Okay, gorgeous. The waters can also cross out. We have 3 waters here, 4 waters here. 4 minus 3 is going to leave us with 1 water on this side, which is what we see over here. So that's how we write it out now. It's a simplified version of it now. Okay. So what we have here is essentially the reaction that we want to now turn into a basic reaction. So what I want us to pay attention to is the fact that we have 2 H plus ions over here that we need to cancel out because we are in basic conditions. So what we do in basic conditions at this point now is we add hydroxide ions, which is what you see here. We have 2 H plus ions, so we need to add 2 hydroxides, 2 OH minuses, to cancel them out, essentially. Well, not necessarily cancel them out, but in charge to cancel them out. But you'll see what I'm going to do with them in a second. When we add hydroxide on this side, we're going to add hydroxide on this side as well. So we have to make it even, add the 2 hydroxides on this side as well. Now we can combine 2 OH with 2 H to make water, because H plus OH, that makes H2O. And when we have 2 of them, now we have 2 H2Os. So 2 waters we've just formed. So like I said, we've sort of canceled them out in terms of charge, but we combine them. And now we make 2 waters on this side. And we're still left with the 2 hydroxide on this side because we do not have any other H pluses here to combine it with. And so that's essentially our answer. As we get here, we have our answer. So We've made it to the end of this question. Here we have 2 waters with 1 water on this side. We can still further cross them out. 2 minus 1, cancel, cancel. We're left with 1. So there's no water on this side. We still have that 2 hydroxide. This is our full answer, and we've made it to the end of our basic question. Okay, here's another example, and this is in acidic conditions. Okay, so we're only going to add H plus and water, so we don't have to worry about hydroxides at the end. We're just going to keep it H plus and water. So let's divide it into 2 half reactions. So this is our first one. Now, are there atoms outside of the oxygen that need to be balanced? Yes. See, we have 4 and we have a invisible 1. So we need to add a 4 in front so that they are balanced. Now let's look at the oxygens. We have 6 over here and we have none over here. So we're going to add water. We're going to add 6 waters. Because we've added 6 oxygens in our water, we've also added 12 hydrogens. So we need to balance that out over here, 12 H pluses to balance the hydrogens. And, now we focus on the charges. I didn't write them out like I did for the previous questions because I'm hoping we can follow along. You can feel free to write out charges if you need to, practice keeping track of the charges. But here we are absolutely neutral. We're 0 here. Here we had 12 hydrogens, so we need to add 12 electrons to cancel out that charge. So now we're neutral on this side as well. Let's look at our other half reaction. NO3 minus NO. So do our nitrogens need to be balanced? No, they're already balanced, so that's great. What about our oxygens? Yes, our oxygens need to be balanced. We have 3 here, we have 1 here. So we need 2 more on this side to make 3. So that's what we do here. We add 2 waters, 2 oxygens. So that gives us 3 in total here to match the 3 here. Because we added water, we've now added 4 H plus or 4 hydrogens. So we need to balance with H plus ions on this side. So we do 4 H plus. Let's pay attention to our charges once again. We have -1 here. We have +4. And we're neutral on this side. So this is an overall charge of +3. So we need to make this side neutral to match this side. We're going to add 3 electrons over here. And we're good to go. Let's start combining these 2 equations or half reactions. Let's do our quick check. Are our electrons on opposite sides? Yes. Are they the same number? No. So we're going to have to multiply a little bit. If you can pause this video and think it through a little bit if you need more time. If you feel like I'm going a little bit fast paced for you, feel free to pause to take the moment to think. So what number do we have to multiply this half reaction so that this 3 can match the 12? It's going to be 4. So 3 times 4 is 12. So we're going to multiply this half reaction by 4. So that's what we're doing here to get it to 12. So now they match. So we can cross out these electrons. And we can combine our 2 half reactions to make a, full reaction here that we may need to further modify. So let's see. We have 6 waters. Everything on this side is here. We also have everything here, minus the electrons. We're getting rid of those. We also have everything over here, down here, as well as here. We're in the clear. We're good to go. Okay. So remember, we also talked about canceling out waters, so that's what we're going to do. The 8 H2Os, the 6 H2Os, they can cross out. 8 minus 6, it leaves us with 2 on this side, so that's why we have 2 waters over here. We still have 4H plus on this side because the 16H plus can also cross out with the 12. So 16 minus 12 leaves us with 4 on this side. Okay? This is acidic conditions, so we do not need to worry about adding hydroxides to combine with the 4H pluses on this side. So we do not need to worry about hydroxides in this scenario.